What if your network could never lose a packet? Most routers fail when connections drop unless you master static routing. In this video, I'll show you how to manually configure bulletproof routes that never fail, plus when to use dynamic routing instead. Want total control over your network traffic? Let's dive in. Static routes. Routing is the process of determining where to send data packets, which are destined for addresses outside the local network. It is the routers that allow their transfers, thanks to the information contained in their routing tables. It is possible to manually configure an entry in the routing table. In this case, it is called a static route. Or the router can use a routing protocol to dynamically create and maintain its table. To be able to route data, a router must do several things. It must find, or the packet must be routed. The router must also be able to determine from which sources it can learn the paths to the destinations. With this, he can determine the routes or the different possible paths. Among all this information, he must find the best way to the destination. And it must be able to determine if the routes from its routing table to the destinations are recent and passable. The routing information that a router obtains from other routers is placed in its routing table. It relies on this table to know which interface to transmit packets through. The topology that is shown here shows that the router on the left uses the serial 000 interface to access the 192.168.2 subnet. If the destination network is directly connected to it, i.e., if there is an interface on the router that belongs to this network, then the router will already know which interface to send the packets to. And if the destination networks are not directly attached to it, then it will have to use static routing or a dynamic routing protocol. There are two ways a router can learn to forward packets to networks not directly connected to it. We have static routing. Here, the router learns the routes when an administrator manually configures the static route. The problem with this is that the network admin has to manually update the static routes every time there is a change in the network. Static routes are user-defined routes that specify the path that packets take as they travel between a source and a destination. These routes, which are entered manually, allow very precise control of the routing behavior in one's own network. And we have dynamic routing. The router learns routes dynamically after a network admin has configured a routing protocol. Unlike static routes, dynamic routing updates automatically as soon as changes occur in the network. The router learns and maintains its routes to destinations by exchanging routing information with other routers. Static routes are best suited for smaller networks, in queue, where there are very few changes. If a road becomes impassable, then it is mandatory to connect to the routers concerned and manually define the new road to take. Static routes can be used in different situations, e.g., in a small network that requires simple routing, or in a star network topology, or when you want to create roads quickly. On the other hand, it is not advisable to use static routes on a large network, or when we know that the network is bound to evolve. Now, let's see the advantages of using static routing. First, it consumes very little network bandwidth and CPU resources for the router. This is in contrast to dynamic routing, where protocols use router resources to exchange and keep their routing tables up to date. Second, static routes are commonly used in small networks that have few routers. And the final benefit is that static routes allow you to control the paths that the data takes. This is very useful in environments where safety is important. Let's move on to the cons. For starters, dynamic routing will be more appropriate if the network is constantly evolving, because configuring several static routes yourself can lead to many errors. Then, if your network changes and you don't update the static routes, the router won't know about it. This will lead to either data loss or a lot of delay in communications. And the last disadvantage is that as the number of routers increases, so does the number of static routes. On large networks, adding a router with a new network means manually setting up all the static routes of the other networks, but also setting up the new network on all the other routers. This is why it is better to use static routing than on small networks that are not constantly evolving.